have a hard time falling asleep, right? That's the one. Okay, so here we go. What is a scale diagram? Some definitions, right? A drawing in which the measurements are proportionally reduced, right? Measurements are proportionally reduced or enlarged by a constant factor, right? Every dimension is affected by the same amount, right? Maybe I'll use a different color for this one, but it is from the original, right? It's always based on the original. What happened to the original slash actual? What happened to that? And the scale diagram answers that question, right? And then we have two things that are related, but they're stated differently, right? What is a scale? A scale is the ratio of a measurement of the scale diagram to the corresponding measurement on the actual original object. So I will just highlight the ratio, right? Different units are okay, but no decimals. And for a scale, it's a ratio, and I will give you those formulas or the notations down here in this big box, so don't worry about it too much. A scale factor, right? Similar to scale, but it is expressed in one of these three formats: fraction, decimal, or percent. Very important that there are no units. When we're talking scale factor, we do not have any units there, and you will see why later on. And maybe if you use that other highlighter, if you're using two, I'm just going to highlight, right, the original actual. So it's always based on, we start with the original, right, the one you start with, or the actual. So actual is, I use that more when we're comparing a picture to the, like a picture of an animal compared to the actual animal, or a picture of a car compared to the actual car. But we always deal with these two, and we see what happened to them, right? So scale, when it comes to when you have pictures, blueprints, etc. We're going to use diagram and actual. Diagram, right? This is a ratio, right? Actual, like that. And when you're making copies, right? So you start with one, you make a bigger version of that one or a smaller version of that one. I prefer to use new and original. It makes it easier when you work with a question and you're using one of these two versions, depending on the context. Okay. Same with a scale factor. If you do pictures or blueprints, if you're dealing with, you know, a scale diagram of something, a map, anything like that, I would use diagram. Sorry. Can you undo that one? Undo. K. K is going to be diagram over actual. So you can see how I'm using the same words, right? But we understand that this is how we state a scale, and a scale factor, which we use the letter K for, is written like that. So it's basically stacking this, right? And if it's making copies, if you're making copies, you would rather stick with new, and you divide it by the dimensions of the original. And I want to foreshadow something here. I want to tell you where we're going with this. Right now, I'm just using diagram or actual, new, original. But you will see that these have to correspond to each other. What are you talking about? It has to be like, if you take the length of a diagram, you have to relate it to the length of the actual object, right? You can't do length width interchangeably. You have to correspond. You will see down the road that we can take the area of the diagram and compare it to the area of the actual shape, right? As long as you take the same information from both, the same side, so let's say it's lengths, heights, widths, you name it, radius, radii, right? Snuck that one in there. You just have to have the same corresponding, right? Either one, you use the terminology diagram actual or new original. Okay, so if you're talking maps, pictures, blueprints of a building that is supposed to be built, use these words. When it's making copies of something, like you will see one that a company makes cans, pop cans, right? They have the 355 ml that most pop cans are. Let's say they want to make a bigger version of that. I would use new original. Original would be the 355 ml, and the new would be either the bigger version or the smaller version. The question would have to address that. So highlighting is going to be very important here. Can I just add to this because it's important here? No units. No units. There should be no units. Convert as needed in a sense. Convert to cancel out. Right? This is going to be in a cloud like that. It's just like a little note. Sometimes you would say, well, I need to keep them there because they're not canceling out. Well, do some converting. That's where the conversion comes with us to cancel out. Okay. All right, next. Let's look a little bit further. So now I'm zooming in on the scale factor. You notice that it's K everywhere. Right? So let's say we're talking about the actual car. This would be what we would consider 100%. Like that's the actual car. If K, right, if that scale factor, when you compare it, let's say we compare the actual original to this one right here, you can tell that it got smaller, right? So another way of, we can visually determine that, but we can specifically know that by just looking at the value of K. If we were to take the length of this vehicle compared to the length of this one, K would end up being less than 1. We can also say that K is less than 100%. If you want to compare percentages, you can do that also, right? This would be a reduction. Reduction of original, very important. Original. I'm going to do actual / original, okay? Reduction of actual / original. And then if K is exactly equal to 1, you actually made a copy of the original, no change. So K would be exactly 100%. So if you take the length of this vehicle compared to the length of that vehicle, if you get 1, no change. No change. Identical copy. So it's kind of irrelevant there. If K is bigger than 1, so we can visually see that this is bigger than the original. So we would expect K to be greater than 1 or K to be greater than 100%. And so this would be an enlargement of original or actual. Let me zoom out a little bit because it's cutting off there. Enlargement of the variance. Okay. So let me give you some examples. So let's say you have, if you have any of these, right? If k is 0.2, or if k is 2 over 3, or if k is 65%, any one of these would tell you, indicate to you that this is a reduction of the original, right? All of them, if you were to really convert them, this you can clearly tell is less than 1. This one is 0.67. This one is 0.65, right? So regardless of how you're given that, maybe perhaps it's easier to just turn that into a decimal and see for sure that k is less than 1. So any scale factors that look like this would end up telling you that the original has been reduced. Enlargement, anything bigger than that, right? So 1.2, 5 over 4, 120%, right? Any one of them would tell you, oh yeah, the original has been enlarged. Right? This is 1.25, this is 1.2, right? So there we go. I will highlight this one more time. The scalar scale factor, it will tell us what happened to the original or the actual. So it's always telling you what happened from the original to what I have now, right? It could be a diagram or a copy of it. So if you do this in your study sheet, I would probably just have these three there, right? If this is less, then it's a reduction, identical copy, enlargement, right? Just a small little section there to remind you. And when I put something in caps or highlight, that's probably important to combine those, right? Okay, here we go. And I want to give you a subtitle here. Converting scale or scales, I'll say, to scale factors. You can bet that that's going to be on a test. This right here is a scale. How do you know? Well, there's a ratio, right? There's the colon there, 2 different units, which is all acceptable for a scale, but not acceptable for a scale factor. And let's go. So we go k is equal to, we just take the scale and write it as a fraction, like that. As it stands, you cannot cancel units, right? So we're going to have to do some converting. Watch what I do. I tend to take the biggest unit and convert it to the smallest. That's what I tend to do. So on the side here is 50 meters times, right? I know that 1 meter has 100 centimeters, right? So I just cancel out this. So 50 times 100 is 5,000. So 5,000 centimeters. Okay. I will make a note, convert largest unit to smallest. So basically, right, if you're given feet and you have inches as well, convert that to inches, right? If you're given kilometers, turn that to meters or centimeters, right? and so forth. Like you always convert the largest unit to the smallest. I would advise you to do that. It's not like it has to be, because it will still be correct if you just convert and have the units the same. So I can now say that 1 centimeters on top, and instead of 50 meters, I will just replace it with 5,000, right? Right? Now you can cancel out units. Right? You've achieved what you wanted to. Right? You can cancel them out. And so K is equal to 1 over 5,000. I will, though, state it in all three formats. Okay? Fraction, decimal, percentage. If you have your calculators, something's going to happen here that you need to know how to fix that to help you out. Unfortunately, you cannot change this feature on this calculator. It will go scientific notation as soon as there are more than 3 decimals. So let's say you want to find the decimal of this. You go 1 divided by 5,000, and it gives you that notation, right? That is really saying this. Let's write it down before I give you the trick here. Note 2e to the negative 4. It's really saying 2 times 10 to the negative 4. I'm quite certain most of you, if not all of you, have encountered scientific notation, right? In science, physics, chemistry, right? You encounter this. So that's what that's saying. I feel like this calculator, they should be able to manage to get it to write it like this or to show it like this, but it doesn't. So you either know that it's 2, the decimal starts here, right? You shift the decimal 4 places to the left. Okay. So I always tell my students, start with a decimal here, and then go 1, 2, 3, 4 places, and you fill in the valleys that you've created with zeros. So that's really the number we're after. I will show you a trick though that's way easier than that. Okay, so watch this. This is also just a note. All you have to do is add 1 to this. So you got to go plus, just take that answer and add 1 to it. You just have to make sure you ignore the 1. Does that make sense? The 1 you just added, just ignore it, but then you can tell, oh, it's 0.0002. 0.0002. Multiply that by oh, here you have to be careful. I'm going to take the answer before there and just multiply that by 100. And that's 0.02%. And note, since k is less than 1, we can conclude that the original / actual has been what? Has been reduced. The original has been reduced because k is less than 1. We don't know the context around it. There's no word problem just yet. We could then later say, hey, the original car has been reduced, or the right, like we can fill in more later on, but we're already practicing here. See, a small example had so many components to it, right? You had to do some converting, You have to understand that when scientific notation shows up, how to handle that, right? And I actually didn't write the trick on here because I'd like it to just stay that, a trick. So just remember when that happens, just add 1 to it and it'll fix the problem for you. I'm going to pause here for a bit and I'm going to ask you to try what I just did here. Do some converting and just turn the scale to a scale factor, which means you can technically stop there. As soon as it's a fraction without units, you're done, right? But I think I will encourage you to do decimal percent as well. So let's come with me to page 13. And I'm going to ask you to do D and E real quick here. Notice that the answer is already there. The number in brackets is already the answer. So you can kind of gauge yourself, but kind of cover that up for now. And focus on the work you would have to show. This is on page 13, right? To turn that scale to a scale factor. Okay, so go for it. If you need your study sheet for the rates, go for it. Go over it, and then we'll continue with the rest. Convert the following scales to scale factors. So your drill. This one is very similar to the one we just did. So 1 centimeter has, if you just show me some work on the side, that's all I require, right? So that's 2,300 centimeters. Nice. So it's 1 over 2,300. Technically, you're done, and I think you come up with the same issue here. Does the +1 trick work on this one? It does. Yeah. So you just focus on, right? And if you want to take that and turn it into a percentage, I just take that one, and that would be 0.04%, right? Which, yeah, you could have just grabbed this one, multiplied by 100, or shifted the decimal over 2 spots. It's up to you, but just make sure the percent symbol follows it. And then for the for E, centimeters and feet, so it's not quite even the same system, right? So 1 centimeter and 1 foot, you cannot cancel that. So let's convert the feet to centimeters. I think you would all agree that you'd have to convert it to a smaller unit. So we know that 1 foot has 0. Oh no, I gave you the centimeters, right? Sometimes I'm a little rusty on my memory there. Cancel, cancel. So that's, you didn't really have to do any converting really, right? That's just it. No surprises there. So I can just rewrite this. I can just say that 1 centimeter and 1 foot represents 30.48 centimeters. Now you can cancel. And what you can do there, let me see if this works. I haven't used it very often, but if just follow me, 1 divided by 30.48, right? And this is the trick. You press on math, and the very first option is turning something into a fraction. So if you just hit enter, math enter basically, right? And then enter one more time to actually make it run through. There it is. It's a simplified fraction right there. You wish you had this one, right, for APR. So that's where I got that answer from, the 25,762 most likely. So 25 over 762. But let's say it didn't ask you for a fraction, right? All you would have had to do is just go 1 divided by that 30.48, and you get 0.03 But if you multiply that by 100, you get 3.28%. Just like I have it here, right? Let's see here. Math 1, right? Enter, turns answer into simplified fraction. That's the little trick there. Math 1, enter, turns answer into simplified fraction. Quite frankly, I'm not going to require you to simplify fractions, so you don't have to worry about it too much. All right, so we're going to stop there and go back and do some examples that are maybe a bit more challenging. So let's go back to page 11. Back to page 11 we go. Okay. So watch carefully here. It asks us to determine, based on this diagram here, based on this visual, they want a scale that was used to produce the diagram. The scale, right? Just the scale. That's worth highlighting. The scale. This one asks for the scale factor, right? So we're gonna right now just hone in on that. Keep in mind that in this case, it tells you specifically that this is the actual and this is the diagram. So there's not even a doubt that we're gonna have to use diagram actual, that kind of wording. So I'm gonna do A right here. I'm gonna state it like this: diagram to actual. Diagram to actual. You could do new original, but right now I'm sticking with these words, okay? I don't interchange them within the problem. I stick with one. So diagram actual, what do you mean? Well, in this case, you know the length, this would be length, and this would be the length for this particular case. So we know both lengths, so I'm going to actually use that to fill in. These correspond, right? Correspond. That's probably important to note there, right? That they correspond. So the diagram has, can I just say something? Because I will trick you on this. It's not always going to be left, right, left. Just look at the labels, right? Diagram comes first. So I'm going to use the 14-inch to 25 feet. That is it. You're done. That's the scale. Different units are all right. You just can't have decimals. Okay. I'm just going to go like this. Arrow, length of diagram, length of actual. Boom, done. Now I'm going to deal with the scale factor. So you're going to practice exactly what we just did. I just did this with you. So we're going to go K is equal to 14 inches over 25 feet. We can't have that, can we? Inches, feet, not good. So I'm going to ask you to turn that into a scale factor. Just keep it as a fraction, right? So turn this into a scale factor. Do some converting, clean it up, and get me that scale factor. I know you're capable of doing that. It's going to give you a minute or two to do that. this is your answer in all three formats. I don't know if you noticed, I do this on purpose. It's 0.5 as a decimal, correct? But it's not 5%. This is what the provincial exam would call rounding too soon. So yes, if you round it to, if you want it as a decimal to 2 decimals, that's what it would be. But if you want percent as a to 2 decimals, you have to actually go by what does 14 divided by 300? It's that. When you multiply that by 100, you get 4.67. So you got to watch out. It's almost like we're always going back to this to come up with that. When you want the percent, you go back to this to get to that, right? It's almost like it's branching off. This is my, honestly, this is, if I have a fraction, I prefer this one. Okay, I prefer the fraction overall because you don't lose any for rounding, right? You don't lose your accuracy. I'm going to cut this here because I'm going to do C underneath there. Okay. So C, determine the height of the truck on the diagram. Okay. The height of the diagram. So you want height of diagram. That's what it's asking for. So watch what I'm going to do here. I'm going to use my scale factor, right? The 14 over 300. And we're going to turn over to proportional reasoning, guys. Once you have your scale factor, we know this. Let me go back up. I'm going to go back up here. We know that it always starts with the actual, right? So from this truck to this truck, this is what happened. Everything got affected, right, by a scale factor of K is 14 over 300, which is 0.05, which is 4.67%. So we can tell just by, don't even look at the diagram or at this visual, K is less than 1, so a reduction happened, right? It got reduced, which is to be expected. So we're going to say this. 14 over 300 is our scale factor. And we're going to go over on this side and just take the length. Sorry, we have the height. This is the height of the actual. And this is the height of the diagram. Right? We have height of actual, height of diagram. So you need to make sure you get this part right. We know the 10 feet. Where would the 10 go on this side here? Where would you suspect it goes? So you look at your study sheet real quick right now. You're going to have this one on there. Right? You're going to have this on your study sheet. Where does the actual go? In the denominator, right? So we're going to put the 10 feet down here. And this is going to be the height of diagram. Right there. Okay. So we're going to cross multiply like this and then divide. So x is going to be 10 feet times 14 divided by 300. And that gives you 0.466, and it keeps going, right? If you type this into your calculator, that's what you get. And I know that my answer, right, the only units that are present are feet. So this is actually in feet. Your answer is in feet. Let's turn that to inches because it would make more sense, right? 1 foot has 12 inches. That cancels these out. And then we get our final answer, which is, let's go 140 divided by 300. right? We multiply that by 12 basically. So that's 5.6 inches, 5.6 inches. If you have your highlighters here, I'm just going to highlight this one again here, that when you have a question like this where it's partially unknown, use your scale factor to get you started and then fill in the rest, right? One of them will be blank or unknown, and then just cross multiply and divide and you get your answer. Okay, keep going here. Page 12. So I'm going to do a lot of back and forth, right? So I do a little bit and you try. I want you to try this one. It's very similar to what we've just done. You just have to make sure you read it carefully. Okay? Watch this. The diameter of the animal cell that is represented by this scale diagram is actually this. Very important. Okay? The diameter of the actual cell is that. And it tells you that this whole thing is considered a diagram. Which makes sense. A cell is so small, right? You would have to make a diagram of it to actually see it that big, or blow into it, or zoom into it, right? Knowing what I just gave you here, try to answer at least the first two things here, at least, right? I want you to figure out the scale, and I want you to figure out the scale factor in this particular case. And remember, just attempt it, and if you make a mistake along the way, it's not the end of the world, okay? All right, guys, I'm gonna go over it. So for the scale, again, you would probably want to use diagram actual again. Okay, so take the diagram, that's 4.75 centimeters, and the actual is 0.25 millimeters. Okay. Remember that decimals are not okay. Different units are okay. So I don't know if you've dealt with ratios before, but you treat them just like fractions. So I would multiply the whole thing by 100. Why by 100? Because they have two decimals, right? Both sides have two decimals. So you pick the side that has the most decimals and just multiply it by 10 if there's one decimal, right? 100 if there are two, three, so 1,000 if it's three decimals. So this would be 475 centimeters to 25 millimeters, right? That would be your acceptable answer there. So just watch out for that. Okay, no decimals. So we're close if you have decimals, but that extra step is required. So for B, I'm just going to use this already, right? So 475 centimeters over 25 millimeters. Does it matter if you use this one or this one? It doesn't, right? Either one, you're still saying the same thing. In this case, turning the centimeters to millimeters is the way to go. And some of you already know that 1 centimeter has 10 millimeters. I don't think this is on your study sheet, or on the, but I would assume you would know that. So 4750 millimeters is what we're after. So I'm turning my centimeters to millimeters. That's how I choose to do it. Right? So that's 4750 millimeters over 25 millimeters. And you cancel that out. And if you, in this case, if you divide that, right, it gets you exactly 190. If you multiply that by 100, you get 19,000%. Note, K is greater than 1. Therefore, in this case, the actual has been enlarged. Okay, this is a very important note that always in the back of your head, whenever you find scale factor, you should be able to answer that. Okay. See? Oh, I did already. Sorry. My note actually turned into an answer. Okay. D. If the nucleus has an actual diameter of 0.12 millimeters, determine the diameter of the nucleus in the diagram. Okay. So I will use, maybe you can use this one, any one of them in this case, because there are no decimals anywhere. So how about we use the 190? 190 over 1. I don't know if you that's what I would recommend. It's still correct to say 190, but if you say, because quite often we're used to our scale factor being a fraction, right? And we know that the nucleus of the actual diameter is 0.12. So 0.12 millimeters goes here, and this would be the diameter of the diagram. D of diagram. That's what I'm going to call it, which is, I turn that into X later. So you go 0.12 times 190, right? 0.12 times 190 divided by 1, which is really not necessary. So you get 22.8 millimeters, right? Or if you want to turn that into centimeters, that would be 2.28 centimeters. Both are correct. So if they had given you the diameter of the diagram and they asked you for the diameter of the actual, which in this case we were given already, so that wouldn't be the case, but just watch out for the wording and what's unknown there. Okay. This one, let's just quickly do this one because I want to do scale diagrams yet. If I ever ask you for the scale factor used in this case to create the new shape, so if this is the original, it stands to reason that this would be the new, right? That's just common sense. So watch the wording here. You're making copies, and don't let the prime throw you off. A prime is just to differentiate between the 2 points. So in this case, I will use new over original. That should be on your study sheet. You should not mix them up. But I'm going to use the wording that goes with my example. Now you have to choose. What is it that you want to do? Because if they're similar, every dimension has been affected by the same scale factor. So if you don't mind me highlighting, right, I'm going to compare this side to this side to get my scale factor. Okay. So there are no units here, so we don't even have to worry about that. But I'm just going to count 1, 2, 3, 4 units here. And over here it's just 2. Okay. So the original goes here, and the new goes here. Okay. Can I just make an arrow? This would be the width of the new, and this is the width of the original. It's very important to correspond, right? That's 1/2, which is 0.5, which is 50%. Okay, so there we have it. So the reduced fraction, comma, the decimal, comma, the percentage. And we can tell that a reduction happened just visually, right? Or if you have a different highlighter, you could have compared the length and the length, right? So this would be 1, 2, 3, 4, 5, 6, and this is 1, 2, 3, right? So you could have gone 3/6 and notice that you get the exact same thing, 1/2, 0.5, 50%, which is to be expected. Right? This would be the length of original. This is the length of the new, in this case. Maybe I'll do one of these here. I compared the green and I compared the pink values there. Regardless of how you do it, if you have if you have a question like this, you should come up with the same scale factor. How do you know for sure that it has been a reduction? K is less than 1. A reduction of what? Of the original. Right? Always starts with the original or actual, right? So it depends on the situation. Can I ask you to scrap this here? I don't like these questions in the textbook, so don't even. Some of them are confusing, so I'm just going to tell you, don't go there. Don't use your textbook in this case. This is my grand finale here, the scale diagram. I will give you some more examples down the road. But by the way, these are also scale diagrams, right? They're the original and you made a scale of it, right? Scale version. Let's go to page 15. All the way to page 15. These are the steps for working with scale diagrams. If I ask you to make a scale diagram, right? I will make it very clear. If you are asked to draw a scale diagram, use, right? So some in the past, students kind of missed it. So if you're asked to draw a scale diagram, these are the steps I want you to use. Convert actual dimensions using the scale. Draw the object using conversions in step 1, and then label using actual dimensions. Okay, so these are actual dimensions. Dimensions, guys, length, width, height. Every object that you can see has dimensions, all right? Actual dimensions. And here's my scale. Notice that at different units, not a big deal at all, right? But we're going to do conversions. Convert. We're going to go length first. And so we're going to go 1 centimeter over 2.2 meters is equal to, hold it. You should remember that the bottom always has, what should be used in this case, diagram, actual, or new versus original? Well, if you're making a diagram, right? So this would be diagram, actual. Remember that order. Okay. So when it comes to length, You take the length of the actual, right, and you put that here, 12 meters. And you will notice that in this case, the units line up nicely. Okay, it's okay to have different units in this case. So X numbers of centimeters will be required to draw your length. So this would be 12 times 1 divided by 2.2. 12 times 1 divided by, that's 5.45 centimeters. I should have added a grid here, but it is what it is. You're going to have to use a ruler instead. So for the width, I did the length calculations. I came up with this, right? For the width, I start the exact same way. It's going to be X number of centimeters. For a width, watch here on the top, I go width, right? That's normally associated with my width, the second number. 8.6 meters will have X number of centimeters. So here it would be 8.6 times 1 divided by 2.2. And there you get 3.91 centimeters. So this is the diagram length, and this is the diagram width. So remember, you're trying to sketch this on your piece of paper, so it needs to be converted. So let's draw. So if you have a ruler, I only have 2 here. I don't think they'll help you a whole lot, but have a ruler for this unit. You're going to need it for other units. So I'm just going to make my length 5.45 centimeters. If you're off by a little bit, it's not the end. So I'm going to go from here. I'm going to start with this one. So my length goes this way, width goes that way. So I'm going to go 1, 2, 3, 4, 5.45 is about almost 5.5, right? So that's good enough. 3.91, it's almost 4, but not quite. So I'm going to go 3.9 millimeters there, or centimeters, sorry. Draw that. You do the same thing with the other side. And try to make sure it's about the same. We're not going to sweat it if you're off by a hair. Okay, I'm not going to take marks off there. This is the diagram. And this is what throws students off. I'm just going to allow you to do both. I'm done. Like, I don't want you to lose marks for this. Go ahead and do this. Go ahead and do that. But then you're also going to come alongside and just call this 12 meters in brackets, and you're going to call this 8.6 meters. Let's make a deal and just do it that way. Because I used to take marks off when you put the wrong one in. And so now I'm just going to get over it and just like, you know what, do both and then we're okay. Because when you build this thing, you would obviously know that this is the one that the room should actually be. I'm going to stop here. I'm done. Thank you guys. You're great. I'm just going to tell you which questions I want you to try. Okay? No. So for homework at the bottom of this, page 5, and it looks like a lot, but it's not a whole lot, guys. In the workbook. And I will give you a little tour of this, of the homework, because I want you to know what's coming your way. Page 5, if you go to workbook, it looks like this. There's some converting, some of the stuff we've done in the past. First couple of days, some scale factors. Here you're doing similar work than what we just did now, but there's no drawing required. But here, there's a drawing here. Draw the scale diagram of the chip. So there is a scale diagram on page 5. What's happening? And then you might wonder, what's up with page 6? 6 is actually a copy, but I made it in page 7 and 8 has just more space. You can actually do the work on page 7 and 8. So just ignore page 6, right? Just ignore page 6. Everything is on page 7 and 8. But watch this. 8 is really just one question, right? So it seems like it's a lot, but if you think about, a little bit of sketching here and there, I will post the answer key and you'll be able to see how you did. And that is it. It gets a little tricky, especially if you don't do some of these on your own, guys. Okay? If you do some of these on your own and then you come back tomorrow, I will take it a little further. You're gonna have a better grasp. You're gonna watch out for things that confused you. Okay? So just make sure you do that because the test is coming up soon. All right? Thank you.